Obtain the Fourier series to represent f of x equal to sin mx in between minus pi to pi such that m belong to z. We know f of x is equal to a0 by 2 plus summation of n is equal to 1 to infinity an cos nx plus summation of n is equal to 1 to infinity bn sin nx. We have the function is sin mx, and also we know f of minus x is equal to sin m into minus x, that is sin of minus mx, that is minus sin mx, we know this is odd function, hence we can decide that it is odd function. Therefore a0 is equal to 1 by pi times integral from minus pi to pi sin mx dx. Since sin mx is an odd function, from minus pi to pi it should be 0, or we have generally we say integral from minus a to a f of x dx equal to 0 when f of minus x is equal to minus f of x, and it will be twice integral 0 to a f of x dx when f of minus x equal to f of x. And also further we have an is equal to 1 by pi times integral from minus pi to pi sin mx into cos nx dx. Sin mx into cos nx dx. We shall take f of x equal to sin mx into cos nx. Now we shall replace this x by minus x. Therefore we can get f of minus x equal to sin m into minus x into cos n into minus x. Sin of minus mx is nothing but minus sin mx. Cos of minus nx is cos nx. Therefore this is an odd function, hence the integral is 0. Now we shall take bn is equal to 1 by pi times integral from minus pi to pi sin mx into sin nx dx. This is an odd function. Product of two odd functions is even. Hence this is 1 by pi times 2 times integral from 0 to pi sin mx into sin nx dx. From this formula I have got that bn is equal to 1 by pi twice integral from 0 to pi sin mx into sin nx dx. Now we shall start from here. Bn is equal to 2 by pi integral from 0 to pi sin mx into sin nx dx. Now we shall recall a formula that sin c into sin d is equal to 1 by 2 cos of c minus d minus cos of c plus d. If you observe this formula cd, now bn is equal to 2 by pi integral from 0 to pi 1 by 2 times cos of mx minus nx minus cos of mx plus nx dx. Now if you recall, bn is equal to 2 and 2 get cancelled here, 1 by pi. We shall separate that integrals now. Integral from 0 to pi cos of, taking x as common from this, m minus n into x dx minus integral from 0 to pi cos of m plus n into x dx, m plus n into x dx. Therefore we get bn is equal to 1 by pi integral cos x is sin m minus n into x divided by m minus n is a constant, we shall divide by that, from 0 to pi minus, this is integral cos x is sin of m plus n into x by m plus n from 0 to pi. Bn is equal to 1 by pi. For first limit it is sin of m minus n into pi by m minus n minus sin 0 by m minus n. This is the first thing. Minus, now for the second limit it is sin of m plus n into pi, m plus n into pi by m plus n minus sin 0 by m plus n. This is the second limit, and you know this term is 0, this term is 0, sin 0 by 0. Now we have sin these two terms, therefore we shall reduce that. Bn is equal to 1 by pi 1 by m minus n sin m pi minus n pi, this is nothing but m pi minus n pi sin a minus b, sin a cos b minus cos a sin b n pi minus 1 by m plus n into sin a plus b, that is sin a cos b plus cos a sin b, sin a plus b sin m pi into cos n pi plus sin n pi into cos m pi. Here if you see sin n pi is equal to 0 for any solution, therefore this term is 0 and this term is 0. Therefore we can write Bn is equal to 1 by pi 1 by m minus n into, this is sin m pi cos n pi, this term is 0, this term is 0, sin m pi into cos n pi minus 1 by m plus n sin m pi cos n pi. Now if we simplify this, Bn is equal to 1 by pi sin m pi and cos n pi is common, that we shall take as common. Here in these two terms sin m pi cos n pi is common, sin m pi cos n pi into 1 by m minus n minus 1 by m plus n are the remaining terms. If you see, now we shall proceed. Bn is equal to 1 by pi sin m pi is as it is, cos n pi is minus 1 whole power n as we recalled before, and this is m plus n minus of m minus n, that is minus m plus n by m minus n into n plus n, m minus n into m plus n, that is Bn is equal to sin m pi by pi into minus 1 whole power n, here minus m get cancelled, that is 2n by m square minus n square, m square minus n square. Now we f of x equal to a naught by 2, that is f of x is equal to a naught, we know a naught equal to 0, that is 0 by 2 plus summation of n is equal to 1 to infinity an into cos nx, an is equal to 0, that is 0 into cos nx plus summation of bn sin nx, summation of n is equal to 1 to infinity. Bn is this thing. We shall write that like this: 2n sin m pi into minus 1 whole power n by pi into m square minus n square into sin bn into sin nx. This is bn. 2n sin m pi minus 1 whole power m by pi into m square minus n square into sin nx. This is 0. This is 0. Therefore, f of x should be equal to this thing. f of x equal to sin mx. Sin mx is equal to summation of n is equal to 1 to infinity 2n sin m pi into minus 1 whole power n by pi into m square minus n square into sin nx into pi. This pi would be here, pi. This pi and this pi get cancelled. So 2n sin m pi minus 1 whole power n by m square minus n square into sin nx. Sin nx is equal to summation of n is equal to 1 to infinity 2n into minus 1 whole power n sin m pi by m square minus n square into sin nx. Thank you. Please subscribe to my channel. Sin mx.